Hello students, so today we are going to start a new topic called electronic effects, right? So this sounds very simple, but the point is this is the most important topic of whole organic chemistry. If you want to learn organic chemistry without mugging it up, this is where you need to be the best, okay? So what do you mean by electronic effects? So simply electronic effect means effect due to movement of electrons, right? Now which kind of electrons are available in a molecule? So we have two kind of electrons, shared electrons and unshared electrons, right? I hope my handwriting is readable. So shared electron means they are bond pair, sigma bond pair and pi bond pair. They are shared electrons. If you talk about unshared electrons, there will be lone pair and unpaired electron, which is not shared between two atoms. Okay, so these are different types of electrons available in a molecule, and the effect caused by these electrons can be called electronic effects. Now let us take a simple reaction. AB plus C gives AC plus B. Now what happens in a reaction? From reactants you get products, right? If you look at this reaction, you see this AB bonds break and AC bond is formed during this reaction. So if I put reaction simply, this is nothing but bond breaking and bond formation. So a reaction can be said to be collection of bond breaking and bond formation, right? Now if you look at here, if you look at it other way, so there is a bond pair shared between A and B, right? Now, when the reaction takes place, this bond pair has moved between A and C. So, can I say that this bond pair has moved between A and C? So, in other way, we can say this is nothing but electronic movement. A reaction is nothing but electronic movement. Now, you can ask me, why should this electron move? Why electronic movement? The simple answer is to gain more stability. Yeah, that's correct. So whatever is happening, that is happening to gain more stability. Now the next question you can ask, how will they gain more stability? How? Okay, so let's say there is a positive charge and there is a negative charge. Positive charge means this is a electron deficient species, and negative charge means electron excess species. Okay, now I have a simple question for you guys. Everyone know this: a charged species is more stable or a neutral species is more stable? The answer is simple: a neutral species is more stable. The example is us. If the charged species was more stable, we would be charged only, right? So if I touch you, that I'll get an electric shock, but that doesn't happen. That means we are neutral, everything is neutral around us, which are stable. That means this species will also try to get stability by getting neutral. And how is that possible? If the electrons from excess side can move to the deficit side, then both of them can get neutral. So one reason of electronic movement is charge neutralization, right? Now what could be the second reason? So I'll give you another question. Let's say there is one atom which is carrying two negative charge, and in the second system there are four atoms where these two negative charge are distributed. Now can you tell me that which system is more stable? So you can take a pause, think about it. So let's say, which system has lesser charge density? There are two negative charge distributed over four atoms and two negative charge distributed over one atom. So I will say this system is more stable. Why? Because here the charge density is less. That means it is closer to neutrality. So the another way of getting neutrality or getting stability is charge delocalization. What do you mean by delocalization? That means that these charges or electrons, instead of localized over one atom, they can move around different atoms. Okay, so this is, now I'll give you another example. Let's say in a reaction, what happens? We get products from reactants. Now we can classify the reactants into two categories: substrate and reagent. Reactants can be classified into two categories: substrate and reagent. Based on what? I'll tell you. So I'll give you I'll draw a parallel reference over here. That is not a hardcore fact, but you can use that for self entertainment, right? Now reagent, I can compare them like boys, right? Now why I am comparing them with boys? Because they are more reactive. They are reactive to propose the girls. So substrate are like girls who are like inert. Now again I am telling, this is not something controversial. This is just for a reference, to have some entertainment, and this has nothing to do with the fact. Okay. So let's say if there are 1,000 boys, if I took at the ratio, there are 995 girls. That means for each 995 girls, there are 1,000 boys. That means 5 boys are going to die alone. Okay, so nobody wants to die alone. So they are always more reactive than the girls. Whereas girls know that the ratio is favoring them. So they are like inert. So the same thing happens here. The reagents are more reactive, substrate are less reactive. And when a reaction takes place, reagent will attack substrate. Okay, fine. Now if you look at the reagents, when you go to a reaction, if you look at the reagents, so they can be further classified as electrophiles and nucleophiles. Okay. Now what is electrophile and what is nucleophile? Sorry, I have to erase this part for convenience. Now what are electrophiles and what are nucleophiles? So simply electrophiles means electron loving species. Right? You can just break the name. And what is nucleophile? Nucleophile means nucleus loving species. Nucleus means in this case positive charge. Okay, so these are electrophiles and these are nucleophiles. Now can you tell me that which species can be electrophiles? Simply the atom or the species which have vacant or empty orbital to accommodate electrons. If you have no room available at your home, then you cannot accommodate gas, right? The same thing happens here. Those who have vacant orbital to accommodate electron can act as electrophile, whereas those who have lone pairs available to them, that is a unshared pair of electron, they can donate to an electrophile who needs the electron, right? So let's say we can give a positive or negative charge. So during a reaction, electrophile needs electron and nucleophile can give electron. So they are looking for each other. Okay, and what happens here? The nucleophile will donate the lone pair to the vacant orbital of electrophile and a bond will be formed. So that is how during the due to the electronic movement, the bond is formed between electrophile and nucleophile. So these are the reasons of why a reaction takes place. What happens during a reaction, right? Now you see, there are different types of electrons available in a molecule. It can be shared electrons, it can be unshared electrons, and there are different types of reactions we know, and the reaction mechanism is also different. So what is reaction mechanism? Now we have already told, if reaction means breaking of bonds and formation of bonds, or we can say electronic movement, reaction mechanism simply means how the reaction takes place, or how this bond breaking formation takes place, or how the electronic movement takes place. Okay. Now there are different types of electronic effects. So what are the types of electronic effects? So first one is inductive effect. Then we have resonance, mesomeric effect, hyperconjugation, electromeric effect. Right, so there are different types of electronic effects available, and if you want to really learn the organic reaction, it is not possible to mug up the organic reaction, so uh, you'll be lost in those reactions. So the best way is to understand the organic chemistry, and if you want to do that, you have to start with this part. You cannot do organic reactions if you think, okay, let's skip 11 and go to class 12 while mark it up for 1 year and give the exams. That is not going to happen. This is the foundation of whole organic chemistry, and that is what you have to learn first, right? So maybe in the next class we'll start with this electronic effects. This was just an introduction, so today we'll finish this here. So thank you for joining me in this class. See you in the next class.